And welcome to the discussion this morning. It's going to be a very, very active one, and we're have a number of experts that are with us today. And I think the need for the communication between the clean room industry, obviously the medical industry, non-woven fabrics, and all these other technologies are really needed to solve these problems. And so we do have a lot of experts from the clean room area today. For instance, Wallace Leung, who not only is involved in the clean rooms and a number of other things, but very, very involved in the face mask nano fibers. And Christine Sun, who was a longtime AFS member and active on the boards and things, is going to be also a longtime expert in these areas. And then David Shelep and Jim Agalloco are both in the decontamination area experts. And then Barry Garfinkle is an ex-technical director at Merck and very, very knowledgeable about the biocontaminants and the technology and so forth. And then Jeff Mathers is director of global marketing for Purafil, and they have a media which actually destroys the viruses as well as captures them. And then I will be hosting the agenda. But the bottom line here, and is kind of mind-boggling, is it looks like there could be 3 billion people wearing reusable masks. And surprisingly enough, there's a company called Vogue Masks that's got retail stores in China and got N95 respirator type or N95 quality masks that they sell for $33 to people like the person envisioned here. And we'll get into all that. And first, we're going to talk to Wallace, then we're going to get the mass technology overview from Christine. But then we'll get into decontamination with Jim Agalloco and David Shelep. And then the virus destruction with Jeff Mathers. And then reusable media. And on the reusable media side, things are happening by the moment. And in China, they are already into the hundreds of thousands, 300,000 reusable, washable N95 masks per day. And the premier of China was in one of these manufacturing things just this last week and said, we want to get everybody back to work and let's make 100 million of these. So there's a lot going on. And then summary and discussion, and then going forward. But what I'd like to do is I'm going to turn briefly to the presentation I'm going to make, but then have Wallace comment a little bit about it, and then we'll go back to Christine's. But basically, you've got I just said we happen to be this end of the slide, but you've got a company selling masks for $33. That's they have the beauty. They have all the tests from Nelson Labs and so forth on viral efficiency and N95 and everything else. So I wanted to talk to Wallace and get your feedback, Wallace, on where you think everything's going, and particularly with the nanofibers and the ability of nanofibers to be washed and to take out to meet N95 or N100 efficiency.
Okay, thanks very much, Bob, for inviting me to share my view on the topic. I've been working on nanofibers for the past 15 years. We have developed a number of technologies in nanofibers. Some of them are used for face mask, means like for handling so-called small amount of particles, aerosols, and then the other technologies to handle maybe what we call in air conditioning, in which you actually build up a dust cake, like for that. So we have developed technologies like what we have known in the market as multi-layers. And then the other one is what we call composite media, where we have coarse fibers in front of nanofibers. All of these are patented 10 years ago. And then some of them are being commercialized. And again, I do not want to comment on other people's design, but there's one thing which I want to point out very interesting is I know that we want to have a rewashable mask. Nanofibers in the past is very, or actually it's very difficult because you're talking about fiber of the diameter out maybe 500 nanometers and smaller. They're very, very fragile. And then I also hear people talking about lamination, try to laminate. Lamination means to make it all kind of attached to something else by lamination. With that lamination, you basically make the nanofiber mat more two-dimensional. The pressure drop is tremendous, okay? And in fact, one of the things that speaks to it is like when you make an N95, if you look at the specification carefully, the inhaling pressure is 35 millimeter of water, corresponding to about 350 Pascal. And then exhaling is about 25 millimeters or 250 Pascal. This is way too high for people to use it as like a very high pressure drop. It's uncomfortable. That's one of the reasons why they have to put in an N95 is to put in a valve, a bypass valve. Mm-hmm. So you can suffocate very seriously. Now, what I think nanofibers obviously, again, I don't want to comment too much in detail how they made it, but then you can actually make a more protective, a more breathable.
Code followed by the pound or hash sign.
Yeah, yes, we got somebody. Yeah, go ahead, keep going now. Yeah.
Okay. What we have done was like we made a mask which is 1/10 the pressure drop of like what is being specified, so that people can breathe a lot more easily. Instead of 25 to 35 millimeter of water, we are making 2.5 to 3.5 millimeter of water using nanofibers.
Oh yeah, so that's interesting. So, and do you need the valve like this mask does then, or not?
The valve, without a valve, people would suffocate. They would die from heart attack. Okay,
okay.
If they wear it for too long. Now, the other thing which I think I just want to comment is like people talk about a lot about reusing it by washing it, but you have never seen a single piece of data that shows like a filtration testing of a wash mask. We have done something like that on somebody who claimed that their mask can wash 3 times. But after we wash the second time, when we look at the filtration efficiency, it drops down to very, very low. And in fact, some of the fibers are being destroyed just through gentle washing. So again, this is something which I want to mention is like I have not seen data recording about after it's being rewashed. But again, the pressure drop by itself is extremely high. So people are uncomfortable by wearing this, and this would deter people from even putting on an N95. But obviously, in a case when people have to go into a so-called high-risk environment, they have to put something like that. Now, on the other hand, we have started developing something in which we are able to put electrostatic or nanofibers for the first time, because in the past, electrostatics are being put on microfibers. We can develop, again, face mask in which the pressure drop is 1/10 of whatever is being recorded in here, about maybe 2.5 to 3.5 millimeter of water. So that's something which is down the works.
Yeah, that's interesting. I think this is a washable filter, and they've been at this since 2013. So I think it'd be very interesting to get your feedback on this particular design here. But I think what you're doing is invaluable. With the electrostatics, what happens? can they be washed if you have the electrostatic effect on the nanofiber?
Actually, water would not discharge the electrostatics, okay? And then, so this is something which is known because there's a lot of misconception that electrostatic can be destroyed by moisture. And then for properly charge a mask, the electrostatic stays pretty much there.
So
yeah, that's been known with many membrane filters that you can retain the electrostatics. There are many absolute and depth type filters in the farm industry that are utilized that maintain electrostatic charges with aqueous materials. So that's consistent with what's being said.
Yes. Also, the fact that if you look at what you were talking about, the volt mass was like a $33 US, and then we are trying to produce nanofiber face mask, which are less than $1 US per mask, and in other words, you can use 33 days. I mean, $33 you can use 33 days. So again, not counting on the fact that after you wash it, what is the efficiency that you can obtain? That is a questionable. It's something that nobody actually put out or dare to put out what the performance is after repeated washing.
yeah, that's a good point. That I noticed that this Vogue mask sells their mask for $33. Of course, they're not. They're all out of stock now. But because you mentioned that $30 level, right?
Yes, $33. That's what they put out on the web. So you can buy 33 masks for $1 per mask. And I think in normal production, they should be cheaper even with nanofibers and even with disposable. And in fact, some of the masks, you can actually use a little bit of alcohol or maybe what we call non-alcoholic disinfection liquid to spray onto it and then to basically do the disinfection. In fact, one of the topics that which you have mentioned here is on hydrogen peroxide. And I don't know whether you guys are aware. I mean, like I have been working with a company in Hong Kong, working for the mass transit. The mass transit in Hong Kong is very, very efficient. Every 2 minutes you have a train. So we have been using robotic hydrogen peroxide to disinfect the cabins. So that is something which is proven to kill bacteria and virus and all the biologics and also microorganisms. So again, that could be something that can be considered in the future for reuse masks.
That type of sterilization is actually utilized in the pharmaceutical industry. I don't know if Jim's on. Jim, I'm sure, can also talk to this, but the issue with hydrogen peroxide, and typically what we utilize is high concentration peroxide, which is then volatilized into a vapor. And it's very good at killing bacteria and viruses, not a problem. The challenge is penetration. It's much more of a surface decontaminating agent than trying to penetrate. As an example, if you were to package these masks in cartons, say 100 per carton, as an example, and try and sterilize by hydrogen peroxide, you will not succeed. If you were to do individual masks, it still likely would be a challenge, depending on how thick and how porous those masks really are.
I think that's a very good point, because if you look at mask from the Vogue mask, there are 4 layers, and then you have to basically to let it soak in. And the other thing which I want to point out, Bob, is like after you wash the mask need to be completely dry.
Yeah, good point.
With a 4-layer mask, it is extremely difficult to dry it up. So it may have to take it for a long time, put into some kind of oven and other things. And again, disinfection is an issue, because if the mask is not dry, if there's liquid in there, it would have 2 bad effects. First effect is it blocks the pores so that it will become less permeable. The second effect is because of the moisture, you can actually cultivate bacteria. So that is even worse. So this is very important on reusable or rewashable mask, is to make it dry. And then a 4-layer mask make it even more difficult, similar to what has been mentioned about penetration of using disinfectants.
That's probably the biggest challenge. I did a little homework last night, Bob, and I went online just to look at the 3M mask that they have, the N95 spec type mask that they use, quote, for hospitals and healthcare. And the other issue that I noticed there is the outside is typically polypropylene or I believe polyvinyl plastics, but the inside also has a cellulose material. So that cellulose material may be an issue with some of these potential treatments. And the other is they also evidently add either carbon or they add other materials that are actually antiseptic in nature. And obviously, once you wash these things, some of those, what I will refer to as coatings, and that may not be an appropriate term, but may be lost.
Yes.
So that's another I think item that needs to be considered. Typically, go ahead.
Not only is this being detached, but also the danger of inhaling them, especially if they have nanoparticles.
Okay. Yeah. The other thing, just for a reference point, this virus, an N95 has to be certified to be 95% efficient or better for 0.3 micron particles. Now, this virus is about 125 millimicrons. So the reason these masks are effective, they wouldn't be that effective for naked virus, but if the virus is on a dust particle or a particle containing, some mucus or saliva, etc., that's probably why they're getting a better efficiency. But it isn't just based upon, the N95. I think the N95 is just something that says it's at least this good, but it's not an absolute as far as potentially removing that virus.
I think that's a very good point. In fact, recently I've submitted 2 papers on the same topic as what has been said. It's like N95 is based on 0.3 microns. What I have done was I look at some of the technology, the best technology that we have on the nanofibers, targeting at 100 nanometers. Okay, and which is like what was just said is it's about 120. In fact, one of those information released earliest from the Chinese CDC, so to speak, they said the smallest is 60 nanometers, and then the largest is 140 nanometers. So on average, it's about 100 nanometers. Again, that 100 nanometer is a very interesting size, because that's what I call the nano aerosol. Because if you look at even flu virus or maybe other coronavirus like SARS, they are also about 100 nanometers. So it depends on what is being attached, what nuclei or carrier is being attached. If it's attached to large stuff, no problem, like what is being said, okay, high efficiency. But if they are attached to smaller stuff, again, that could be something very dangerous, because they could be potentially attached to something even smaller than itself, so that the size, the largest size is still 100 nanometers. And then the standard, which is being set, was many years ago, was at 0.3. That was based on microfibers. But again, things have changed. So, but people have no way to go to, and then still using that being a standard. So that is something which is a very, very good point.
Yeah, I think along that line, you mentioned the small particles. They're doing a lot of research on a church choir in Washington State that met in February kept all the social distancing. Everything was sanitized. Everybody was at a good distance from each other. There's no way they could have, they thought, infected one another. But 45 out of the 60 people that attended that 2-hour choir singing group came down with the coronavirus. And the experts believe that this deep voice singing could project thousands of small virus particles from deep inside the lungs that would travel through the air, and that's the only explanation they have as to how that short interaction could cause 2/3 of the people there to come down with the coronavirus. So I think that's it.
Something about filtration here, and filtration works in two ways. Not everything is removed simply by size. So while the N95 has about a 0.3 micron, capture 95% of particles larger, it can capture smaller than that. There is another means of filtration capture: impingement, impaction, sometimes even attraction by kinetic forces. And so you can't rely on this just saying, well, it's a 0.3 micron N95, it's not going to do anything less. It will. It does work. There's a tortuous path through any of these masks. So don't forget that.
Absolutely.
Okay. Yeah. Let me make a point is actually we didn't go into details of that. There are two major mechanisms, a so-called non-electrostatic mechanism that's responsible for capturing submicron particles. One is known as the diffusion. Diffusion usually works very good for small particles. Usually maybe 200 nanometers and less. Okay, the smaller it is, the best it would work, because the higher the so-called diffusion coefficient. And then the other mechanism is called interception. The interception is the one just being mentioned. It's usually very good between 200 nanometers to about maybe 1 micron. And then also we have inertial impaction, but inertial impaction only works when the particle is more than one micron. And then if you have electrostatic, the electrostatic would work, I would say, maybe from 200 nanometers to large ones. But for very small particles, electrostatic does not work because the dipole moment is very small. So again, I mean, when we are talking about the standard, we did not go into the details. But again, we agree that again, the mechanisms could be, there's what we call U-shaped kind of curve. The U-shape, the so-called most penetrating particle means the lowest efficiency in the past for microfiber filters. They correspond to 0.3. That's one of the reasons why NIOSH set the standard at 0.3. But once you start using other filters and other fibers, then this so-called penetrating particle would move around.
I think that we've got, this is a very good conversation, and what I'd like to do is to set up as many webinars, even starting next week, to go into all these aspects of the science, and because I think it's very important, because I think there's a lot of misinformation about what gets through and what doesn't get through these masks. But the one thing I wanted to touch on before we move off of this and move on to Christine was, you mentioned the dollar per mask and $33 per package. But this Vogue mask has been selling, and I think they're selling each of the masks for $33. And they've got a worldwide clientele that buys these masks, and I think it's a whole new paradigm if, in fact, you can sell a mask for $10 or $30 or something like that, and wash it, and people are willing to pay for it. So, would you agree there, Wallace, that this is a mask that's 30 times more expensive than the ones you were talking about? Is that just to make that clear?
Oh, yes, absolutely. More than 30 times more. Yes.
Yeah.
This would have equivalent to buying at least more than 30 masks for the same price if you have the same amount of money to purchase some of those so-called non-reusable masks.
You're right. Yeah, well, I think that's great. And Wallace, let's probably set something up next week earlier in the morning. Maybe if we can at least set it up at a couple hours earlier or something like that, and talk to you, and then talk to I think splinter off into a number of different conversations on these things, because I think there's a lot of misinformation out there. But the bottom line is, and CDC and everybody's coming on board and say masks do something, and then you've got the potential for everybody around the world to be wearing a mask from time to time when they're in a what we would call a non-safe zone, and whether it would be the high end where you're paying $30 for the latest fashion in your mask, as well as all these things, or whether it's less. It's a huge potential to explore here. So with that, I think we probably should move on, and so I'm going to ask Christine if. Whoops! We passed Chris. I didn't mean to get that one here. Here's the one we need. Yeah, Christine, why don't you give us in your background a little bit, and then go into those slides there.
Okay, thank you. Can you hear me okay?
Yes.
No, there's an echo now.
Yeah, there's a little echo now. Are you? See if we can.
How's now?
Good. Good.
All right. Thanks, Bob. Hello, everyone.
Hi.
I hope all is well with you and your family, safe and healthy. I'm Christine Sun of Waterloo Filtration Institute. In response to recent increasing concerns of COVID-19 and the many requests we received recently on face masks for protection against COVID-19, and we hosted an open webinar, and all the presentations, you can have that from Bob or from Waterloo Filtration Institute website. And next, I am going to overview some of the key points. And of course, we actually very thankful for the panel experts in joining us for this discussion, and we did receive a lot of questions and good comments. And this is something that probably I hope that we will continue to address in our future webinar, and to provide some useful information to public in terms of to protect themselves from these contagious viruses. And
Christine, Christine, I just wanted to mention that Bob Burkhead is working with us on the concept of measuring the particulate load, say in a room, and measuring the efficiency of a recirculating air filter system to reduce particulate as a surrogate for the viruses. So I think that's one of your panel experts is doing some work that's going to be critical to the industry.
Yes, actually, this is one of the key points. We talk about a face mask, and also another concern is how's your environment, especially for like hospitals, our frontline health workers, their environment, because this disease contagious through, we call it right now, commonly says is aerosol, those virus aerosol in air. So in our panel discussion, we do have Professor Tan from University of Waterloo. I will show you some of the interesting results from their research. And Peter Chai, he is a professor from University of Tennessee. He's very, very knowledgeable and also inventor for many of the electrostatic charged medium, which is used right now primarily for face mask application. And Professor Dr. Bart from University of Georgia, and Vincent from Taiwan, and Eric from Australia, and Tom Baptist. We have certain information. So let's just go to slide 9. Actually, I want to just give some of the highlights, what included, and you can refer later from the whole presentation. So first point is here is a face mask is a filter. It's based the same filtration principle. So primarily including, we call it directly sieving and also indirect interception, which includes inertial impact, just like Wallace mentioned, and the Brownian diffusion. And Wallace mentioned this for the, based on the diffusion phenomenon for the small particles, and also interception. And for face mask, there is one important filtration mechanism play here is electrostatic charge. And currently, primary filter technology or filter medium technology based on meltblown electric nonwovens. That is on page 11, slide 11, please. So this most popular face mask today, they use the 3-layer nonwoven laminate with electric meltblown layer in the middle, which is a core component in terms of prevent small particles penetration through the face mask. And also you guys probably, if you look at the industry, we receive a lot of requests initially from mainland China, and right now from North America, and the market is very short of the meltblown electrostatic charge medium for face mask right now. And besides these traditional meltblown technologies, we actually, with recent development, like Wallace just mentioned, nanofibers provide alternative options for face mask, which is based primarily for mechanical filtration mechanism. It's not primarily like electrostatic charged medium, its own electric filtration mechanism. So on this slide, you can see on the left, it's a nanofiber face mask. And this is probably new to a lot of people. Actually, the nanofiber face masks on the market already have 4 years, probably, as I know. And on the left is actually the commercial product on the marketplace to show you the structure of nanofiber face mask. And in the middle, instead of electric static charged polypropylene medium, is nanofibers. And it also shows you the small particles are captured between nanofibers. On the right of this slide is some of the research work by University of Waterloo, Professor Tan. They produced also, I think they actually did a lot of research on nanofibers as well for high efficient filtration purpose. And of course, it can be used as a face mask as well. So the point here is, besides traditional electric static charge meltblown technologies, we have some alternatives there. Nanofiber is one of them. And let's move on to slide 20. Once again, you can have all the presentations later on if you want to, the further information or all the information related to this seminar. So here's one thing I think is very interesting to let the public know is that we normally say the face mask N95 or even P100. So people probably have a kind of thinking is they are very well protected because they wear a face mask that is able to block 95% of small particles or some of the 99. And in reality, so this is one of the tests is on this chart, the up curve is the efficiency measured by face mask. Actually is just with the instrument, and you measure the efficiency. And another line, the blue curve, is the face mask you use a human head, and then you measure the efficiency at the breathing nostril, human nostril. There's a model to measure the efficiency. So you can see one very important message here is the actual efficiency is much, much lower than efficiency when you actually measure the product in a lab. Why? Because when we wear the face mask, majority of them, it's not sealed well. So if you, in other words, if you sealed very well, like this one, if you sealed very well, you put just the tape around your face mask, you can see the efficiency actually much, much higher and close to what manufacturer claims when they send the filter mask to the marketplace. So this is very important. One thing is face mask does provide some of the protection. However, it's to a certain degree. So basic thing is stay home, and if you need to go out, wear a face mask. And also, we have this Professor Chai from University of Tennessee. He shared some of the information. Slide 31, please. Information very interesting is because people actually right now are looking for face masks. So there is a need to reuse, to consider how we can reuse that based on current situation. They cannot buy face masks, or there are not enough face masks for our health workers. So there is a lot of experimental data from China because their market is requiring for face masks during outbreaks in China. So the only concern is because the face mask is all based on electrostatic charge medium. Can we go to slide 31, I think? Yes. From this chart, we can see that number one message is the blue bar presents the meltblown wave without charge, before charge. And the green bar is the same meltblown wave, but the efficiency of electrostatic charge. It tells us electrostatic charge play a very important role here to block small particles or to capture small particles. And the green, and the blue bar next to green bar is the efficiency of heated in the oven, 70 degrees C for 24 hours, which we think at this condition, coronavirus will be killed. So under this condition, it seems that oven treatment did not reduce the efficiency significantly. With that saying, let's give our message. If you're really, really short of face mask and you need to reuse that, and oven heat is a method. And also you have other method, is a potential method for that, for reuse. And there are a lot of experimental data from China at that time, and I review all of them. They're pretty much consistent with Dr. Chai presented in our seminar. And that's probably the key point I want to share with you here. And with that, I open for any questions if you guys have. Thank you.
Very interesting. Yeah, questions? I had a question from the standpoint of, say, you're wearing these masks to and from work, would you want to use your kitchen oven? And if so, what precautions would you want to make sure that you don't contaminate the oven?
Yeah, it's actually in that center we have Eric, who actually he has been with this face mask business for many years, and the point that he brought out is there are strictly hygiene procedures required when we consider any kind of face mask reuse. So for the face mask, it's designed for disposable, one-time use. For such kind of things, you do need to be very careful. You handle that. You don't use your hands to touch the front of your face mask, and you use that. You can use that with your kitchen oven. That's not a problem. Under heat for 30 minutes, the virus will be killed. So just when you handle that, you need to be carefully for every possible kind of virus spread during this process.
What, can I ask a question?
Sure.
Yes.
When you mention after heat treatment, what type of heat treatment are you mentioning?
The heat treatment, just as you can see on this slide, 70 degrees C, 24 hours. Actually, you don't need 24 hours. I'm not like a biological specialist, but it was reported that under 70 degrees C and a half hour, all the coronaviruses will be killed. So yesterday, actually, I read more of the environmental data, even 100 degrees C in oven, or also you can just put it in boiling water. It seems the charge still play a very important role in keep the efficiency. That means it's not lose the charge. However, it's important to know, as Wallace also mentioned a little bit, is never ever use alcohol for any kind of purpose, to disinfection or hygiene purpose, to do with electrostatic charged face mask, which is primarily in the marketplace. All of them are the charged face mask. If you just look at this chart, if you charge that with, if you do that in alcohol, the efficiency will drop from 99% to 37%, some of them even lower. So IPA or alcohol discharge or disinfection is not work with electrostatic charge face mask.
Can I ask another question? So how does this relate with like PFE and BFE for let's say a disposable mask? I mean, so you have this 99%, 98.5 at, let's say, on 70C after 30 minutes. How does this relate to if you put it in some type of oven? How does this relate to the capability of the mask itself?
That's actually the capability of mask itself, the efficiency. Actually, the data shows that here you still have about the similar efficiency. So you can see the 98%. So it's the overall or the structure did not destroy anything. So it's just under heat for a certain time, half hour to 1 hour should be fine. That's suggested by the.
Okay. Is that particle filtration efficiency and bacterial filtration efficiency? Is that what these represent, the green and the blue lines?
No.
Right. So all of
No. I think Christine, he was asking whether the green and blue lines represent, one is a PFE, the other is BFE. No, that was not the case.
This is just the particle efficiency.
So this is PFEs then, right?
Yeah, yes, particulate filtration efficiency.
Okay, okay, good.
And is this taking into account not just the filtration media, but the actual, does the mask seal as well? Does it perform as well as far as allowing the individual to breathe through it, etc.? Or is this just taking the media and asking the question, what happens to its ability to remove particles?
And this is a very good question. So for this slide, it's just this is just the filter media. And in China, they did the test for the face mask instead of face mask media. So they also have the similar result.
Yeah, because to your point, the filtration media is always interesting, but if one doesn't seal it properly to the face, to the individual, it isn't very effective. And in fact, those masks, typically people are taught how to place them on to get a good seal. So if those materials that are utilized for establishing the seal are adversely affected by the 70 degrees C, then we haven't achieved our goal.
Right. I think that this very much depends. And also that brings one point is I did this kind of electrostatic charging technologies years ago from 1992. So when we actually developed that technology, we found out we were very excited. After charges, the efficiency initially 30 and then increased to 99. And at that time, the charge technology, it's not that stable. So after 1 week, we noticed that the efficiency dropped because the decay. It's very much depends on what kind of technology you use for electrostatic charging and what's the durability. So it's one of the results give us some indication, but it's not the kind of conclusion for all of the face mask and for all the electrostatic charging technologies. It's just a reference for us. Again, the face mask is designed for one-time use. Anyhow, we actually think it's just a one-time. However, in case you are in a critical situation, you want to use that, probably this kind of data provide you some of the helpful information.
Okay, Christine, what's the difference between the two sets of data? One is 98% and the other one is 82%. So what's the difference between the two sets of data?
One of them's a medical mask.
So,
yeah.
This is just two different sets of the electrostatic charged media. So both of them show that that there is no significant impact of the heat treatment at 70 degrees C, 24 hours. So this is just a two sample set.
Is that what you recommend in terms of 24 hours to put it in the oven?
I think this is quite different. Actually, in China, they talk about just like 30 minutes, or because they actually refer to how long that virus will stay. If they recommend in China actually like 30 minutes and 70 degrees C, that should be fine.
But how would they know unless they test whether the virus is still there? So it is a very difficult test because you can test bacteria, but testing the virus is very dangerous. It can only be tested in so-called high security virus lab, and then there are only a few in the country.
Exactly. Actually, they did this a lot of test results. I reviewed actually from there. They have an assumption. That means under this is 57 degrees C or half hours, the virus will be killed. So under that assumption, they did all these tests. They said, okay, this is higher enough and this is longer enough to kill all the viruses, and to see if there is any efficiency decay after this heat treatment.
Okay.
Yeah, WHO had actually done studies on SARS, obviously a similar coronavirus, and 56 degrees C for 30 minutes reduces the viral burden by about 4 logs. Yeah. Keep in mind, with viruses, you get a log reduction, but saying you kill all the virus is a very difficult thing, because oftentimes there are very large log numbers as far as the initial concentration. So one might say, I have 10 to the minus 3 probability of having live virus, or 10 to the minus 6, which is how we typically express it, but it's all dependent upon what was the initial virus concentration. Sometimes one gets virus concentrations of 10 to the 10. In which case, even 4 logs reduction is interesting, but I still have 6 logs left. So those are all things to be kept in mind. The healthcare professionals obviously are going to be exposed to much higher concentrations than the casual, if you would, person walking through a street or walking at a decent distance from someone else, even if they're infected. And in fact, one of the hypotheses now the epidemiologists are using, the people that have a very severe reaction, it may be dependent upon what was the initial dose of exposure.
Yep.
And also keep that in mind. We say the face mask is a filter. However, it's a loose, open filter.
Right.
So never ever think about it. I have a face mask. I be very well protected. No, you actually have a protection to a certain degree. You still have the risk to be affected by the virus around you. So it really depends on how you wear it, what is the product, what's the efficiency. So the message actually we try to constantly to spread this to the public is face mask provides you some protection, but anyhow, if you can stay home, stay home. Face mask just to a certain degree to protect you to be affected by the viruses.
I think we probably should move on at this point. Sorry, this is a great conversation. And again, what I'd like to do is possibly set up another a number of webinars next week on some of these more specific subjects where we can have the leisure to discuss each of them in more detail. But we probably should try to cover, we have some very interesting presentations still remaining here, including Jim Agalloco is going to talk now about decontamination. So Jim, the floor is yours.
Okay, thank you, Bob. It's Agalloco, just so you know.
Right.
One of the things we've got to understand, and this was really clear from Christine's presentation, these are systems. Yes, there's an N95 layer, but you've got other components, and we have to deal with, the straps, because the straps, if they lose their elasticity, if they lose strength and break mid-use, we've rendered a very good mask useless. We have to deal with the materials, and they may be on upstream and downstream side of the typical polypropylene layer. We have to deal with what effects happen there. Can we block things getting in? Can these cause problems and reduce the efficiency, or be damaged in such a way the mask is rendered useless? And lastly, there's in some of the mask designs, there's a metal nose piece. Of all the pieces in the puzzle, that's the least concern. Next slide, please. And here, just as an indication, and this is what, from a reuse perspective, compounds the problem rather dramatically. We don't have one mask that we're dealing with that applies universally. You see these 6. None of these are identical to the ones we've been talking about before. You solve the problem for one, you still have others. We do not have a single answer for all these particular designs. They all have potentially different weaknesses, different materials, different risks associated with it. So it makes it a lot harder. When we're talking about reuse of these, any one of these may be coming back to be reused. One of the first things that has to be considered is, can I sterilize a mix of masks together, or do I have to have an individual process for an individual mask, which I think is probably the only safe way to proceed, but that complicates things endlessly. Next slide. So these are the basic processes we have out there, and I just put these in because these are what you see potentially being done for sterilization. And there's a nuance here that we have to understand. Masks, we like to have them sterile from the standpoint is we don't introduce an infectious agent close to the person wearing the mask. But a virus isn't alive, so really we don't talk about sterilization. We talk, as Barry did, about log reductions, and we then really speak to a decontamination. And how many logs is enough? It's hard to say. What is an infectious dose of the virus? No one really knows. It's too early to tell. What the problem we also find is when you look at these processes, they've all been evaluated very heavily for sterilization. Very few of them have been studied from a viral destruction standpoint. There's anecdotal evidence, there's things that suggest it works, but there's not a lot of hard data. Okay.
Can I ask a question? Sorry.
Sure.
Can I ask a question on a dry heat of 170 degrees? Polypropylene melting point is about 160. So
right.
160.
Let's go to the next slide. And you'll see what I basically have done. In the next slide, we basically eliminate dry heat. It's really not a good option.
Mm-hmm. Okay.
It's a terrible option. Radiation is a reasonable option, but typically 25 kilogray, that has to be done at a remote location en masse. It's great if you're commercially producing millions of masks. It's not really good if you're trying to reprocess 5,000 or 10,000 or even 50,000 a day. It's really not a good option. So next slide, please. So yeah, those are the possible methods. You know, in terms of thinking about them, you're saying, okay, yeah, the nose piece, we can kind of ignore it. It's a piece of metal, not likely to be affected. Typically, these are stainless steel. The straps and the added layers, as you see, this is one of the bigger variations that we find. We don't know the effects. Dry heat, as you know, at 170 is really destructive of a lot of polymers. So you can see all those question marks. Radiation is also pretty damaging. Polypropylene will stand up, but some of those other elastomers that are used in the straps or in the other layers, it may not manage it. So if you flip ahead, you'll basically see I've dropped those two out. I don't see either of those as real viable alternatives for reuse and re-sterilization of a mask. So it leaves us with steam, gas, and vapors as things we might consider. I'll move on to the next slide. So I looked at this in two ways, whether you could do this process in the hospital, because ideally that would bring the used mask under the best possible control and shortest travel distance back into use. Yeah, we could use steam for that. Gas, some hospitals have a limited gas sterilization capability. Usually they have it associated with endoscopes, and great, but not a lot of capacity. So very limited capacity. That's a real shortcoming. The vapor process may be locatable in a hospital, but they do not always have the equipment. What we've seen from Battelle and Duke is a hydrogen peroxide generator system. Most hospitals don't own one of these. Now, yeah, it's a $100,000 item, but do we have them in supply? Get them out to the hospital, set them up and run this? We just don't have that capability today. It's going to take some time. From a process standpoint, the time of execution, steam is a real easy. Gas is going to take some time. Even that gas plasma thing, 4 to 6 hours to turn it around. Vapor, 2 to 3 hours. The biggest part of the vapor, and this goes back to what Wallace said and what Christine both said, we have to dry this thing out. We have to have this mask dry at the end. Okay, and the vapor kills most effectively when it condenses on surface as hydrogen peroxide liquid on the surface. So yes, that'll kill quick. That'll destroy the virus quick. But how do we get it back off so that we don't destroy the filtration capabilities of the mask? Implementation time is about the same. Steam capacity is going to depend on what the hospital has. I mean, do they have enough extra autoclave time to be able to process masks? Yes or no? I can't discern that. Typically, the gas is very limited, and the vapor, in theory, you could take a common room, seal off the air supply, and run this process. So how many masks could you fit in a room? And see, I'm looking at this rather differently than a commercial production standpoint. I'm thinking these masks are going to come back in bulk in some form of a bag. We're going to disperse them throughout the room, and we're going to treat them. We're not going to have time to have a carton, process, packaged, individual wrap mask. I don't see that as being part of this process. If the crisis is immediate, the means of reuse has got to be very quick and very sudden so we can alleviate the shortages as quickly as possible. So looking ahead on that, you'll see I take the gas process out. I just don't see it as really viable. So just advance the slide, Bob, please. I just don't see that working. The capacity's not there. The process time's not there. And so we're left with steam and vapor. So let's go to the next slide. So with steam, we're going to use a hospital sterilizer. Capacity unknown, but we have to look at what the effects are. These masks are designed to be sterilized once. So we're jumping in with a product that's now been used to some extent, and we're going to try and bring it back and literally cross our fingers and see that we don't have either damage to its structure that won't be further affected by the steam process or the vapor process. Now, the vapor process is we need this generator. We need to retrofit a room. We could probably do a lot of them, but now again, what are the effects? And can we dry it out? Similarly, the same problem occurs with the steam. Can we get the condensed steam out of the multi-layered mask so it's dry? Because as we saw, wet systems do not work as well in these N95 masks. We're going to obscure air passageways. We're going to affect retention. We're going to have a great number of problems. So both of these processes do involve some moisture, so that's problematic. And lastly, the real stinger is go back and I solved this once, great. And now a different supplier of masks comes in, or we have in this crisis situation multiple masks around the floor. We can't all expect them all to work, and we don't know what's going to happen. So there's lots of conflicting problems here. There's potential, but it's not straightforward. So that's pretty much what I've got to say. There's not a lot been done. All we know about is how to sterilize masks, which is killing spores. We don't know a great deal about how much it really takes to viral decontaminate a mask and what processes would work there. These are the two I see as feasible in the near term. How quickly we can get them up and running, anybody's guess. So, questions?
Yeah, would you want to comment on the Duke activity and the Battelle related activity?
Well, again, they focused on sterilization. They focused on, Geobacillus serothermophilus, nice critter, but that's something that's tough to kill, chemically or by thermally. It's not a pathogen. It's not a virus. It takes an awful lot to kill it. So those processes are probably way overstated. The Battelle cycle looks like about a 3-hour cycle. We don't need anything like that to get rid of the viruses. I can understand. I think I saw one report, and I don't know how accurate it is, that 0.5% of peroxide liquid will kill a virus, or let's say eliminate potential virus in 30 seconds. So that's quite a big difference between 3 hours and 30 seconds. Now, that means destruction of the virus. I still have to get the peroxide off, so it wouldn't be a 30-second process. But you can see there's a huge gap between what we have knowledge on and what we're trying to achieve here. The viruses don't have resistance to either of these particular sterilization means, but we don't have enough data to know what we really have to deliver.
Well, what you're saying, I think Battelle is looking at decontaminating 100,000 masks a day in their Ohio facility immediately. And
that's a drop in the bucket, Bob.
Yeah, sure.
I mean, yeah, great. More power to them, but do that 500,000 times over.
Yeah, that's a very good point. Very good point. Other questions?
I'm not saying it doesn't work. It's just not an answer to an immediate crisis.
Yeah. Although if the destruction can be done in more quickly, could they up that production from 100,000 to double or triple it per room?
They probably could, but again, we need to have infrastructure. We need to have that investment. I mean, it's not hard to replicate that design. It's not all that sophisticated.
If there was a material that was able to withstand higher temperatures but still reach N95 rating, do you think that a dry heat would then be a better option?
Probably not. Again, think of this as a system. Yes, that'll work for the mask. Well, what do you do with the straps? Will they sand it? Put a rubber band at 160, 170 C and see what happens.
Right.
We got to look at this as a system. This is not just the mask focus. Yeah, and we can preserve the effectiveness of the mask, but what do we do with the rest of the system?
Well, Jim, it is actually when we talk about the heat, it's really relatively lower heat. It's 70 degrees C. I believe most of the material in the face mask still can probably perform or stay the shape with that 70 degrees C or 60 degrees C.
Yeah, that would be great, but people don't consider that as sterilization, and that's again
right.
A disconnect. What would we accept as a treatment? And we don't have the data. How long does it take to destroy the virus at 70 C? I mean,
yeah, I think to Jim's point, if we really want to look at what's the temperature profile for inactivation kinetics for this virus, then one could say, okay, for this virus, I can get rid of, and I'm making this up, 5 logs in 15 minutes at 60 degrees centigrade. It doesn't tell us about, obviously, anything other than this virus. But that may be the kind of compromise we need for this type of activity. The other thing also is, as any of us that have gotten into commercial sterilization, it's one thing if you have one naked mask, but if I start packing these things into cartons and I have 1,000 in a carton or 100, and I place 100 of those cartons in a sterilizing device, I have a certain time it takes for penetration of that heat to the center of those cartons to get that effect. So all of these things become more and more complex if one tries to do it in large commercial quantities, as opposed to, is there a quick and dirty device that one can put an individual mask into, achieve the conditions required, remove it, and go on to another. But perhaps this device has 100 cavities, so you can do 100 masks at a time in a hospital environment. To me, the most important thing right now is to protect our healthcare professionals. Because if we lose them in any quantity, and it appears we are, then we're really in a serious situation. as opposed to if people are stupid enough to go out and have a party on the street. Do you know what I mean? That affects the general population less as far as protecting the most people, in my mind.
Yeah. And Barry, you made a great point. I mean, commercially, where do we find oven capacity to do this in mass? And that, you know, in a crisis mode, we just don't have that. When I think of hospitals, I don't see that. I don't even see that in the pharmaceutical industry, a large number of ovens that could tolerate this. Now, if you could speak to a lot of bakeries, yeah, they could run this process. But, you know, we're really jury rigging something on the go here, and that's really crisis type thinking only.
Yeah, and I think that's really, if we want to help people, I think, Jim, that's kind of how we have to look at this thing. This is not going to be an elegant, you know, validated process where we understand every single variable, et cetera, et cetera. But what can we do to reduce the risk, 3 logs, 4 logs, 5 logs, for those critical individuals that we need to stay healthy as a first step to buy us some time so that, okay, maybe we can develop in the next, you know, 6 to 12 months some antivirals. Maybe we can develop some monoclonal antibodies. Maybe in a year and a half, we'll have a vaccine. But in the meantime, how do we protect the healthcare system? And also, I think we have to include people like, you know, police and the people that are the first responders, and even the people in the supermarkets that are going down like dominoes. Because those to me are the most immediate things. And we'll worry later after we bought some time to let the scientists in the labs help us with the, how should I say it, more precise ways to deal with this situation.
Relative to your bakery idea, what if through the Defense Production Act or whatever, if we just said that, you know, there's got to be one bakery in each key area sacrificed to do this for a period of time.
And the other thing also, Bob, and I apologize for stepping over you.
No.
But the other thing is that bakeries, like the pharmaceutical industry, we have dry heat sterilizing ovens for glass to feed a filling line that are continuous flow. So do the bakeries for making pies and making breads. So the total throughput, if we just had individual masks kind of standing there on trays or something, could be relatively significant in trying to get this thing up and running to get those needed masks for that limited population that I described.
Right, and let me pile on to that. You know, one of the things that people always look at when they sterilize something, they always tend to do it in a wrap so it stays sterile until you open it. Well,
Exactly.
That's the way you deliver a new mask. But in this current crisis, I don't see that happening.
I don't either.
I don't see us bagging and unbagging. So we have a little bit simpler process in that sense. We're going to just take masks, lay them on some rack, run them through, and pick them up at the other end.
Yeah, and the current scenario where even the healthcare professionals, and if there are any of you on the phone, don't get too insulted by what I'm going to say, but when they're given one mask to wear all day, and you know they're going to take it off and put it back on, the probability that they're going to contaminate their hands, their gloves, and then touch a face, etc., is high. In that we're humans and we tend to not even realize we touch things. So if we can get these things, what I will call 99% clean, they're going to be a hell of a lot better off than using multiples of those per day than trying to keep a mask clean for an entire day.
Yeah. And I think the other thing we'll find is if you go to those frontline people and we offer them a mask that's unwrapped, but we describe our process for treatment, I think they're going to more likely want to take one of our reprocessed masks than they would one they've used for a day.
I would agree with that too.
You know, if we have 50 of them that we can give everybody for a week, they're going to feel a lot better than having one a day.
Yeah.
Some great points here, and I hope we can continue on this. But maybe at this point we should hear from David and chlorine dioxide and how that can be used. David, why don't you take the floor here?
Hello there, Bob, and thank you everyone for a very nice talk. Can you hear me okay?
You're coming in a little bit, a
little muffled?
Yeah, there it seems better. There's better, okay. I think, yeah.
Great, and I'll speak up as well. So thank you for this discussion, and I think you made some wonderful points, Jim. It was nice to hear. You covered a lot of things about sterilization in general, and I also appreciate the discussion to bring in our first responders. I'm actually going to meet with my local town to talk to them about what they can do, and I think this is a time where we got to be able to act locally as much as we can to help whatever world we can with this N95 issue. I'm going to talk about a couple different things, and if you could advance the slide a couple places, Bob, that would be great. Yeah, a couple more. Let's go to the need. I put a couple references in here about limited reuse for the N95. It has been anticipated. There's some great reference articles, and I strongly recommend you looking at these. About number one is using ultraviolet germicidal irradiation, and the other one is a discussion by the University of Nebraska that just came out this week, where they were using ultraviolet light to decontaminate masks. Their reference that I put down here is extremely detailed in how they will do it in their biocontainment facility. In the University of Nebraska, that was a site that also worked with Ebola patients in the past. So they've been using some of this as well. What was interesting in one of the articles that I saw about the use of the N95 masks, the one article mentioned that in the U.S. alone during an influenza pandemic, it was estimated that between 1.7 and 7.3 billion of these would be needed. And imagine if that is true, that's just the U.S. That doesn't include Canada and Japan and Korea and China and everywhere around the world, everywhere around Europe. So the demand is quite high. What is important, I think, in what, as Jim spoke, there are a lot of methods that are out there. What is working now and what can we get through the system? In the long term, we'll probably have some great resolution and great ideas on reusing these, even when it is a pandemic, just for practical purposes for reuse. Next slide, please. So some of the methods, and these have been mentioned as well, but I'm going to touch on ultraviolet light and then the gas method, chlorine dioxide. Next slide, please. Let's think about considering these are things that Jim touched on, but I want to think about these 4 points whenever we're looking at a sanitizing or decontamination, a sterilization method. You have to be able to kill the organism. So there are methods like heat that might be able to kill the organism. But to the second point, does it get everywhere? The points where the heat may not get. So the nice thing to think about all 4 of these methods, or all 4 of these considerations, in any method, will it be able to kill the organism in question, whether that's bacteria, virus, fungi, spores. I also have a good slide that I can include or show later that just shows a list of what is easiest to kill all the way to what is hardest to kill. And I think the easiest would be, Jim, you can correct me, is usually vegetative bacteria, live organisms. Viruses are easy to kill, so to speak. All the way down to spores and prions. That probably where it goes. Jim might not be there. Okay, the second point is it must be able to achieve a good and complete distribution. This came up quite a bit for the hydrogen peroxide or any other methods. Will it be able to get everywhere where it's applied? The third point is it must achieve total penetration. When we're talking about masks or other things, will it get into those cracks and crevices? And a lot of that determines the chemistry behind the method or the whatever we're using there as well. And then the contact time is very important as well. You have a method that if it takes so long to use, then will it destroy the material like the straps? And can you get it there on a quick enough time? So these are 4 different considerations that every sanitizing or decontamination method must consider, because if it does a great job killing something, but it also destroys the material, then obviously it's not effective as well, and that's important for the N95 mask. The next slide, please. So let's talk real quick about the UV solution. This hasn't been brought up, but the University of Nebraska study, because, and this is a point with most hospitals currently have some form of UV lights, have robotics, they have systems that you can carry into a room, decontaminate it after a patient's been there. So this is something that most hospitals have. The nice benefits of UV light is that it kills the organisms or denatures their DNA. It's non-toxic to the environment. It leaves no residues. It's obviously very simple to use, and it costs very pennies per cycle. You're just plugging it in. These UVC lights last a very long time. Now, the downside is the shadow areas don't receive a dosage. So in a hospital room, sometimes they will take these torches or these big, tall lamps that into a room, and they'll put it in multiple locations. So they'll dose it for 5 minutes in one area, 5 minutes in another area. That is how they get around effectively using in large areas. The initial cost can be expensive, but the cost per use obviously runs down very inexpensive. Next slide, Bob. Thank you. So this just shows real quick where we are looking in the UVC spectrum and UV spectrum of where we're trying to kill the organism. There's a certain spectrum in that UVC that is effective in killing. But again, as mentioned earlier, it's effective within and it's limited by a line of sight. It also depends on dosage. So you can zap something real quick and it will not be killed, but if you take something to the point where you dose it long enough, you will kill the organism, denature the DNA. Dust and dirt can affect the lights as well. A lot of these lights are coated, so in a dusty, let's say you're in a food environment and you're working around flour and things like that, you would not want to use UV light because the dust and dirt can collect quite a bit. Plain glass and most plastics will block UVC, and it's important to keep in mind that the intensity falls with distance. So you don't want to be 20 feet away from that light because there's no intensity, but if you're a very short distance, and that's how you can make the UV light work better for you. And then it can burn your eyes at the end, so you cannot be really, in the line of it as well. Next slide, Bob. So here real quick just shows the kill spectrum and the lamp out, the output of the UV light, which is around the 265 nanometers. Usually, most UV systems use this technology and are very similar. On the top right there, you see a picture of the torch, and these are the things that will be carried into hospital rooms or areas to do decontamination. The University of Nebraska study, they are using that to decontaminate the N95 masks. Their procedure that I referenced is extremely detailed in how they will use it, how they will reuse the masks, how they will, basically they're putting a couple of these torches in a large room, hanging the masks on lines and decontaminating them, giving them a dosage, and then reusing them. But they're being very diligent as far as one mask for one person, and they watch that person always uses that mask as well. On the bottom right there is just a device for monitoring the dosage. So you can put that device in a room, and then it will tell you the kind of dosage you get for UV light as well. Next slide.
Dave, I got a question.
Yes.
The spectrum of the target of 265 nanometers, that's based on microorganisms. Do you have any knowledge whether that's the right spectrum to take care of a virus? I mean, has anybody studied that?
Well, it's a good point. And I know you know the Chordiasis boys. We're working right now with University of Illinois. They're doing some studies, and it looks extremely promising as far as using surrogate viruses for this is for the chlorine dioxide, but equally as well for the ultraviolet light.
Yep. Okay,
so,
thank you.
There's some very promising things. The studies that were attached as well, using UV light, will reference that as well as far as being effective and using some surrogate organisms or surrogates as well for viruses. So the article from the American Journal of Infection Control that I referenced is a great article as well. Now I'm just showing real quickly a couple of the devices that you can use. On the left side there is just a large unit that you could probably put 20 masks in at a time. You expose them to UV light at all different angles. If you notice, there's UV lights on tops, bottoms, and sides. The shelf in there is a quartz glass with which UV light will penetrate. So in this case, we're trying to give a really high dosage of UV light to a small area, and that will be very, very effective. On the slide before where I showed that torch, that's used in the whole room. However, a lot of places don't have those torches. Hospitals might. The middle slide there is something like a pass-through, just like through in the airports where you pass your luggage through a conveyor. You can create all kinds of systems with UV lights. The challenge right now is getting the UV light because everyone's stressed and may not have that. So I would say if they're in a hospital environment and they have those stand-up torches, to go ahead and start looking at that University of Nebraska study and any of the CDC recommendations on UV light and implement that right away. That's a very quick, effective way. And then some of these other methods, like a pass-through or so, that might be down the line where devices may be reused. But again, University of Nebraska study greatly details how they are using it and how they are using one mask per person. And it's a wonderful study, and it's been very effective for them. So I recommend looking at that and looking at some of their things online as well. Next slide, please. Excuse me. And there will also be other devices where they're putting the UVC bulbs in air filtration air systems, like on the right there. And there are even these small systems on the left, bottom left there, where there's a torch that they will hang in an ambulance, and when a patient is dropped off at the hospital, they will decontaminate the ambulance afterwards before they run it again. Usually there's a cleaning procedure when patients are dropped off in hospitals. And in the middle is something just on its wheels that has a UV light, that has a flexible arm, and they can target that in a certain area. All of these devices also have automatic stops and starts, so that if a person enters a room or something, they do stop as well. So just a real quick show of those as well. Next slide, please. And I apologize, I'm going to go through this very quickly, but we can have another discussion down the line. I know time is a bit of the essence right now. Again, please look at that Nebraska medicine study. It's a powerful study, and it's a great solution that they're implementing immediately. Next slide, please.
By the way, on that, you did send that PowerPoint presentation to us, and I can show everybody at the end. We put that up in our Global Decisions Orchard, so that and we're continuing every day to be inputting data like that that's immediately available. So that is available if you want to get off this call and look at it. It's there.
Thank you, Bob. I will talk real quick about chlorine dioxide gas, and this is a point that Jim made. This is some of these things, they are not available in hospitals. Hospitals are not using chlorine dioxide gas as a routine to decontaminate things. Where there is a lot of chlorine dioxide gas used presently will be in animal vivariums for decontamination. That's used quite a bit. Now, if a research institution has a vivarium, they may be able to use their chlorine dioxide gas equipment to decontaminate. Now, what we're looking at here, as opposed to a vapor, a fogging, or a spray, or a foam, chlorine dioxide gas, because it's a true gas at room temperature, the yellow-green gas, which is good because then you can monitor it with a photometric device. It's water-soluble. Again, boiling point is about 50 degrees Fahrenheit, so it's gas at room temperature, and it's able to penetrate microscopic crevices. So if you look at that little slide on the right there, that's just a little stainless scratch in stainless steel harboring bacteria. So this method is greatly used in food companies because they may have very small little cracks and crevices where maybe a listeria or a salmonella may be harboring. So when they expose it to chlorine dioxide gas, it will get in there and kill in those cracks and crevices. It'll get in those nooks and crannies, which is ideal for the masks as well. But it's also gentle on materials, so it's much gentler on materials than some other methods that are commonly used. It is not carcinogenic, and in the food world, it can be used in organics. There's no residual for this, so it'll sterilize what it needs to sterilize, and then you're ready to go with it. So, next slide, please. And chlorine dioxide gas, it really does meet all these criteria of being able to kill the organisms. It's able to achieve the good and complete distribution. It does get everywhere, penetrates everywhere, and there's a sufficient contact time and concentration. Now, time is of the essence sometimes too. You don't want to take 12 hours to decontaminate or sterilize 100 masks. But what you can do with chlorine dioxide gas, because you're trying to give it a certain dosage, and if we're trying to kill it, I like to use the analogy, it's like barbecue. You can go low and slow or fast and really get it done fast. You may use more gas, but you can get that concentration going and get the kill much quicker. I use the analogy that chlorine dioxide gas is like oxygen in the air versus some other methods that are more like a vapor that don't get everywhere. So that's what the pictures are down there as well. Next slide, please. So here's just a couple areas where chlorine dioxide gas will be used. On the left, there is just a picture of a piece of equipment that helps generate it and monitors the gas, and a picture of someone decontaminating a delivery vehicle. In the middle, it will be used in a chamber to decontaminate all these materials as well, and that chamber is packed full of stuff. Again, because we're working with a true natural gas, it'll get into all of those areas as well. And then on the right is just a picture of the yellow-green gas in an isolation chamber as well, and you can see they stuff this full of equipment to decontaminate as well. So I know in New Jersey, the Chlordices people do offer a service where they will decontaminate equipment, computers, and then they put it in a Tyvek envelope and then send it back out as well. They are not offering that as a service for N95s right now, but they do that for the pharmaceutical and medical device world, which is quite strong there in New Jersey. So next slide, please. So I just put a couple comments there. Please look at those references. They're wonderful. And thank you, Bob, for having those available. And then find out where N95 users need help. If the UV is a solution, that's a great, quick solution. A lot of places have right now. The chlorine dioxide, we are having some studies on that, and it looks, we know it looks good, but we don't want it to affect the materials. But it's looking very good. And I would say there's also some providers that are providing services for decontamination, and then maybe get them on retainer so that they would dedicate their services to you as well. So that's all I had real quick. Thank you for the opportunity.
Yeah, David, a lot of good information and a couple of different technologies to explore. Are there questions that people have? If not, we will keep posting some of your material there, David, and make sure that that's available to. I will show everybody how to get to that a little later. Let's move on then to another approach to this, which would be to put in a media that actually can kill the viruses. And so to do that, we have Jeff Mathers, who's Director of Global Marketing for Purafil, to talk about that with us. Jeff, the floor is yours. It's possible that Jeff is not able to participate in that. We ran over the anticipated number of registrants, and it's very possible that Jeff was not able to participate today because he was late, or I wouldn't say late, but one of the last people to enter. In which case, we will go over this again. But essentially, what they do have a fiber, a media that does attack the viruses and so forth. But rather than get into that, I think I'd rather defer to a subsequent. And we're going to be doing these next week, and we will get Jeff to make that presentation, at that point in time. I do want to get back to the reusable mass and this whole subject again here. Expand this a little bit and go to the slideshow, and from the beginning. The potential here is huge. If you saw the news the last few days, CDC is changing their tune, as are many other experts, and saying, masks are important. You should be wearing them anytime you're outside, public, interfacing with the public. And in Hungary, you can't go outside without one. And several provinces of China, you can't go outside without one, and so forth. So one thing we did was look just at what the meltblown supply would be. China's saying they're going to need 500 million mask wearings a day, with possibly 3 uses. And so we just went through the meltblown calculations. We came up with 438,000 tons per year of meltblown media that would be needed. And for one reason or another right now, we have very limited meltblown media that's available. I think we're being conditioned, as we just have saw in China with the Vogue mask and so forth, that the average person is probably going to want to wear a good mask when he's not considered in to be a safe area. And that's another thing that we can get into later as to what's safe and what isn't safe. but essentially, there could be 3 billion people a day, 3 billion people wearing non-sterilized N95 masks. Maybe they don't wear them every day, so only 30% of the time, but that still would be 900 million uses per day. And if you can reuse if you can wash it 20 times, then you need to make 45 million new masks a day, which is 16 billion masks a year. At a cost $3 for the non-sterile, then the N95 would be a little less than $50 billion. But with the reusable nanofibers, very likely you can get up to N100, you can get it sterilized for applications like that. And if there are 200 million people that need those and they need change twice a day, 400 million uses per day, and divided by 10 reuses and so forth, then you need 40 million masks to be produced today, which is another 14 billion. So at $10 each, it's $146 billion. So the total is that for $195 billion a year, you could make the planet a lot safer. And we have a number of analysis that show that the cost of a life lost is in the neighborhood of $58 million. So you'd have to justify 3,300 lives being saved per year when you consider what the coronavirus alone is doing, or even the hundreds of thousands of people that die from the flu and so forth, that these numbers are pretty easy to justify. But I think it's mind-boggling how fast the reusable face mask with nanofibers is taking over in China. It's got government backing. They very quickly had new types of companies like an infant and children's clothing company using a membrane, nanofiber membrane that's developed by Hanpu, and they are moving forward. And so here is one of the factories that's producing hundreds of thousands of garments a day. 300,000, I think, is going to be their target. And so they're even thinking about ways now to get away from just sewing them like this to more sophisticated methods. But this is where, and I won't go into all this, is that the ways they're thinking about getting away from just the individual sewing here and actually produce a lot more of these. And it turns out that these masks can be cleaned with alcohol or water, and it lasts for 200 hours or 20 times and still maintain its properties. So they're banking on, in fact, the premier of China attended one of these, I visited one of these plants in the last week or so, and talks about the ability to get up to at least 100 million of these a day, and that they to put the reusable masks in the strategic reserve, and because they're not electrostatic and so forth, basically they don't really have a shelf life. And again, the expanding the shelf life expanding the production is a key to all this. And then just to get a feel of what's going on over there, here's another manufacturer that has now come out with the reusable, the cotton-based laminate cotton and the nanofiber laminates. And so they were a beauty mask manufacturer that's now gone into this in China. This is where the premier came to the plant and said, we want you to be making 100 million of these a day. And there's a U.S. company, Vogue Mask, that has been making these N95 quality masks, sells it for $33 and has pretty much gone through a lot of the validation of it. You can see it is a sophisticated mask. It has the various different layers they're needed, and the valve that some of you were talking about. It has the filter efficiency rating. It's designed mainly to be used in urban environments due to the high levels of air pollution. But now, of course, they're sold out for other reasons, for the protection against the virus. And they have 25 different designs, and they have a organic and version here. And what's also intriguing is how widespread these masks are being sold. They even have retail stores now in China. The first one opened up in November 2013, as you can see, somebody visiting one of their stores in an early time. The other thing is that they do have the various different ratings, and it's been done by Nelson Labs here in the United States. By the way, this is a U.S.-based company, and so they've been verifying the bacterial efficiency, viral filtration efficiency, determining the valve leakage, determining the resistance and inhalation and exhalation. So they've pretty much been through all this. I just wanted to put this slide up as well because one of the companies that's participating in the webinar today is Halyard. Would anybody from Halyard just like to spend a couple of minutes on the scope of what your efforts are in supplying the healthcare industry? Yeah, there may not be anybody on there now, but there were several people that signed up from there, and we'll find out more about what they're doing as well. And let's get out of this show. And then one other thing I wanted to show you here was the work that we've been doing in this area, which is probably relevant now. This is an article in Healthcare Development magazine, and we come up. Basically, Cardinal Health came to us and said they wanted a 6 or 8 month study to determine whether single-use garments or reusable garments was the right answer for surgeons. And so we spent the 6 months and made that comparison, and there are a lot of interesting aspects to that. But the most interesting, I think, was we came up with a whole metric called Quality Enhanced Life Days that measures, it takes into account things like comfort and other aspects. It takes into account the future value discounts and tribal aspects of it too, and looked at basically some of these things. But I think one of these things I'll just show you here would be, for instance, if you're washing gloves, look at the TSS that might be contributed to the treatment system by washing the gloves versus the single use. So all those things were essentially taken into account. So, but again, this was a very, very intensive study and did come up with this common metric. And then the other point that I wanted to get to here was where all this material is. That would give you the documentation for background material here. This is our website, and scroll down through this website here, and here's the information on the market intelligence system. So for all the suppliers, we have a way to assess how big the market's going to be, help them move forward. And then we do have this global decisions orchard, and you can click here on the full display. And again, here's a universal rating system that gets into this common metric and many other things. And there's all sorts of other things that are in it. The one thing I'll point out here is if you go down into the global decisions orchard and you go in under title here, it gives you a chronological listing of everything we're putting in for the week. So the N95 mask things and so forth here, if that Nebraska thing isn't in there yet, it will be. I don't see it quite here, but I know our people were putting this information in. But that anywhere, in any case, is the place where you will find that. And any of you have material to be adding, please send it to us, and we'll see that it gets into the system. And so, we basically it gives you a description of what's there, and then links right to the right to the material. So that being said, I think that ends our discussion for today, other than any questions that might still be remaining. So we can take some time for questions if people have them. If not, please get back to us with your comments, what you'd like to see next week, and how we can segment this subject and help move things forward in a very quick basis. So again, thanks for your time, and this is Bob Mcilvaine signing off.